Thank you very much, and good afternoon or good morning or even good evening, everyone, depending on where you're located in the world. Today, we're going to spend some time talking about the different tools that we have available at AWS that sort of fall under the transfer services, ways for you to move data into AWS, and really even ways to move data out of AWS. So we'll kind of go through some of the different things that are available, and hopefully we get to everything and can answer all of your questions. So we're going to start with the overall AWS storage portfolio, and we're not going to go into a lot of depth or detail here because really we're just going to be focusing on these things down in the bottom category. But at the high level, for those of you that are familiar with AWS, you'll know in the upper left-hand corner of this slide we have our block services. Those are for workloads that are running inside of AWS, specifically inside of EC2. So we've got our Elastic Block service and our Instant Storage service. We also have EFS, that is our file offering, where you can get access to high performance, high speed NFS file shares inside of AWS. And then to the far right, we have our object storage offerings with S3 and Glacier, providing infinitely scalable web-based storage and archiving. Now down on the bottom, the things that we're going to be focusing on are the Snowball and Snowmobile family, the Storage Gateway family. We're not going to talk a lot about Direct Connect, but we will talk about third-party connectors, and those are things where our partners have built solutions that directly connect to AWS, to things like EFS and S3 into Glacier. We'll also talk about transfer acceleration and ways that you can get better performance as you're moving data into and out of S3, whether you're doing a large-scale migration or just using S3 on a daily basis or even providing content to your customers. We'll talk about how you can speed that up when your customers are far away from the data source or from the S3 bucket. And then lastly, we'll talk about Kinesis Firehose and how you can stream data into things like S3, as well as some things that you can do in real time to process that data and perform analytics. So the high level of the data transfer services and really where to use them, and I just want to sort of set the stage before we go into more depth about what each of these things do and how they work. But if you're thinking about doing a large batch transfer, moving tens or hundreds of petabytes, even exabytes of data, that's when you're thinking about our Snowball and Snowmobile services. So those are offline processes where you write the data and then the data gets transferred. We of course have our Snowball Edge that was announced at reInvent this year or last year in November. And that is similar to the Snowball, we'll talk about it, but also provides edge computing. So if you need the edge computing functionality, you would use the Snowball Edge. If you are looking to build a hybrid environment or you're augmenting your data center or your on-premises storage with AWS cloud storage, you would use the Storage Gateway. If you have a dedicated network, that is our Direct Connect offering. And then integrating your existing software, that's through the third-party connectors, and we'll talk through a few of those at the end. And of course, moving data over long distances that we talked about will be S3 transfer acceleration. And then the last piece is managing streaming data or IoT data. This would be Kinesis. So these are the things that we're going to talk about today. So get your questions ready and let's dive in. The first thing that I want to talk about is the Snow Family, Snowmobile, Snowmobile Edge, those products. So we have 3 offerings available today. We have the Snowball, which we launched 2 years ago at reInvent, and the Snowball Edge, which we launched last year at reInvent. We'll talk in more detail about those. But these are physical devices that you can order, write data to, and have that data sent back to AWS. And then, of course, we have the Snowmobile, which was launched in November at reInvent, and that is our exabyte scale data migration service built into a shipping container, and that will go up to 100 petabytes in just a single container. So for the Snowball, this is our oldest physical offering for being able to transfer data, and you can see that it's built into a custom case. It will actually support an 8.5G impact. So that means that anything that the shipper can do to it, it can likely survive. It's also rain and dust resistant, And some of the important things to know is that data is encrypted end to end. So when you connect this to your network, we support up to a 10 gigabit network. We have 50 and 80 terabyte capacity units available. 80 is the more recent. And as you're writing data to the Snowball, the data is being encrypted before it ever lands on the Snowball. So that means that once the data is there, it's in a tamper-resistant case. We can, because it's built out of plastic, we can actually tell if somebody has tampered with the case. We manufacture our own screws or have them manufactured where it is a custom screw head, so we can tell if somebody is trying to get into the device that way. And even if they were to get able to get into it, all the data is encrypted, and the important thing is that the key never travels with the Snowball. So when you provision the job, you have the key, and the key is always resident either in the console or you have the key, but it's never actually stored on the Snowball. So it would be very difficult for anyone to be able to actually get any data out of the Snowball and be able to decrypt it because they don't have the key. So it'd be very, very time intensive. Now there's a client that gets loaded for the Snowball, and you load the client onto a machine, and then that allows you to actually unlock the Snowball and to start to copy the data, and it does manage the encryption process. There's an SDK that's available that also allows you to really provision the job, order the Snowball, and go through the entire process programmatically. So you can build in support into an application to be able to work with the Snowball directly. And then we have other things like we support HDFS for Hadoop clusters. We even have an S3 adapter that can run that will provide some limited S3 API functionality as a midpoint to be able to write data onto the Snowball. Now, when you go into the console and create a new job, you decide the bucket that you're going to be writing the data into and how many snowballs you need. And so when you create the job and you choose the bucket, we pre-configure those snowballs so that we know where they're going and where the data is going to be written to. We ship them to you. You get them, unlock them, write the data, ship them back to AWS. And when we get them back, we verify that that they haven't physically been tampered with, they haven't electronically been tampered with, and then we will take all of the data that's on the Snowball and copy it into the S3 bucket that you defined when you ordered the Snowball and created the job to begin with. So the most recent reInvent in November, we also launched the Snowball Edge. In the Snowball Edge, we've increased the capacity to 100 terabytes, and we've also made a few other changes. One of those things is that we've added some local compute, and it's the equivalent of an M4 4 extra large instance. And so now we're doing things like encryption inside of the Snowball Edge rather than doing it in the client. And so that means that we're actually able to write data much faster to the Snowball Edge than we have been in the past with just the Snowball. We've also increased the networking to not only 10 gigabit, but also 25 and 40 gigabit. So now you've got faster connectivity to the Snowball Edge. And with that compute, today you can even run Lambda functions. So you can load a Lambda function onto the Snowball Edge when you place the order, and it's doing S3 put-based triggers. And so you can write data to the Snowball Edge via the S3 API. And with the Edge, the S3 API is built into the Snowball Edge. And when the data lands, you can actually do processing on the data right on the Snowball Edge. So things like converting images to make thumbnails, or video conversion, or even any kind of computational processing. You can do that natively on the Snowball Edge, so that when you ship it back to AWS and we copy all of the data into the S3 bucket, it's already been processed. It's already in a state where it can be used by your application. And this is all done, again, on the Snowball Edge. So with the Edge, a couple of use cases. One is sort of the simple migration use case. You create the job, we ship you the Snowball Edge, you copy the data onto it. Again, you can use an S3 API, and we even have an NFS file interface available on the Snowball Edge, so you can just mount it as a NFS export, as a drive, and be able to copy the data to it. You ship it back and we copy the data into S3. And then you can even do things like data collection, where you collect the data on site, create the job, get the Snowball Edge, move the data into it, move it into S3. But with the Snowball Edge, they're even rack mountable. You can cluster them together. So that means that you can order them, put them in your data center, and actually use them as the main data collection point, and even do some processing on that data. And you can then start to remove individual Snowball Edges from the cluster and ship them back to AWS when they're full, and we'll then copy that data into S3. So when would you use a Snowball or a Snowball Edge? If you're doing cloud migration and you're moving your data into AWS, and again, you're doing the offline batch move, you would order Snowballs, copy the data to it, and ship it back. From a disaster recovery standpoint, so you've been backing up or copying data into AWS, and you have an event in your own data center, and you want to get a bulk load of that data back, you can then order a Snowball or a Snowball Edge. We'll copy the data to it, ship it to you, and then you can move it back into your own infrastructure when you receive it at your data center. And data center decommissions, this is similar to the cloud migration, but if you're shutting down your data center and you're moving a large amount of data, the Snowball or Snowball Edge is a great way to be able to do that in just one bulk move. And then content distribution, we do have some customers that are using Snowballs as a way to ship data out to remote sites. So if you think about something like movie files that could be very large, customers would do all of the processing, the editing, put all of the files in their S3 bucket, and then decide what's going to get copied out to the Snowball, and then ship those Snowballs out to their remote site. So that's a way to do a bulk move of data to those remote sites and be able to have it get there very quickly, and they won't have to download it over the internet or download it over a network connection. So an example of a customer that's doing something similar is Scripps Networks, and Scripps is they have home and garden and food channel networks like that. And they have a lot of data in their data center and on premises, and they wanted to archive it and be able to store it in AWS and get it there very quickly, because moving those large files for those television shows and all of the unedited as well as the edited files takes a long time. And so they're using Snowballs, ordering them, getting them on site, doing the archive straight into the Snowball, and then shipping it back to AWS. We're copying it into S3, and then they can do things like use S3 lifecycle policies to be able to take that data and move it from S3 down into either S3 and frequent access or even into Glacier, and they can build their content archive and be able to store all of those television programs and even the unedited content for long periods of time at much lower cost than when they were trying to store it on premises. Next, we're going to talk about Storage Gateway and ways that you can get access to AWS storage from your own data center and on premises. Now, Storage Gateway, we have 3 different options available. All of them are deployed as virtual machines, and they'll run inside of VMware or Hyper-V, or even inside of EC2. And this means that you can deploy these in your own data center, use them to move data and take advantage of AWS storage. And then at a later date, should you move your applications into AWS and into EC2, you could even spin up a storage gateway natively there in the cloud to be able to access the data in the same way that you're accessing it on premises. So you can see on the left we've got file, volume, and tape options available, and we'll talk in a little bit more detail about all of these. But you can see that on the back end, we're utilizing the traditional AWS storage services like S3, Glacier, even S3 and frequent access, and then of course EBS snapshots to be able to take backups or disaster recovery copies of the data, or even test copies. And we'll talk more about that in just a minute. Now down at the bottom of the slide, you can see that we also use the traditional AWS management monitoring tools, things like CloudWatch or CloudTrail, as well as IAM and KMS to be able to manage encryption keys. Storage Gateway takes advantage of all of these things and helps to extend them down into your data center so that you can use them on premises. Now the file gateway, we announced this late last year, and it went GA at reInvent again in November. And file gateway gives you NFS access to an S3 bucket. So when you deploy the file gateway as a virtual machine and you create an NFS export, you decide which bucket you would like to connect to, and you can have up to 10 buckets connected to a single file gateway, which means you'd have 10 file shares or NFS exports. And when you're writing the data, you can write into S3 standard or S3 infrequent access. You can choose the default, and you can also take advantage of the lifecycle policy with file gateway so that you can write data into S3, have it lifecycle to S3 infrequent access, and even then lifecycle to Glacier once it's, say, 6 months or even 12 months old, and you want to keep that data around for a long period of time, but you're likely not going to be using it on a regular basis, so you'd want to put it into Glacier. Now the thing that you'll notice as well about file gateway is that the connection back into S3 and into S3 infrequent access is encrypted. As well, we store data encrypted inside of S3. So a couple of use cases for the file gateway. The first one, you can see we have an NFS client. We're connected to a storage gateway on premises, which is then connected to an S3 bucket. And in this use case, you'd be writing data into the storage gateway. Maybe you have a genomics workload and you're doing processing, or even a media workload, and maybe you want to do some transcoding or do some other type of processing for the large media files. You write those into the storage gateway, they get transferred into the S3 bucket. And an important thing to note here is that when the file gateway specifically writes data into the S3 bucket, we keep it in the native format. So we don't make any changes to it. We don't obfuscate the data in any way. So if you were to write, say, word.doc, word.doc would show up in your S3 bucket. And that means that you can use all of the AWS tools that are available to process data inside of S3 with data that's been written by the storage gateway using NFS. And so in this case, you can see that we're writing data, it's landing in the S3 bucket, we're processing it with EMR, Elastic MapReduce, the results are going back into the bucket, and then you can see we have refresh cache. And what refresh cache does is it allows the file gateway to find any new data that's been written into that S3 bucket and make it appear as part of the file system in the storage gateway in file mode, so that then the NFS client, and if we were to go back to our genomics workload, the researcher that had written the data that has been processed can now get those results back from the same file share or even from a different file share if they're segregating the data, and all of this can happen automatically. So file gateway is a very easy way for you to be able to take advantage of S3 and S3 infrequent access and all of the tools that surround them inside of AWS without having to change an application. Or if you have an application or a service that you bought from another vendor and there's no way that you can make it talk to the S3 API, this is a great way for you to be able to sort of bring that into the future and be able to take advantage of the AWS cloud using the native file sharing that's already built into the application. So the next one, you can see we have a file sharing use case. In this case, we're reading and writing data to the storage gateway. It is then talking to an S3 bucket, and using cross-region replication, we can then send that data to a remote region. So let's say that you're on the East Coast where I am, and you're writing data into a file gateway that's writing into US East 1. You can replicate that data to US West 1 into another S3 bucket, have a file gateway that's connected to that S3 bucket in read-only mode, and you can actually read that data out. So this is another way that you can distribute data or content to remote sites, give them read-only access to the data, and you only have to keep your main copy, and then it gets replicated out remotely. And then the last piece is our Snowball and Storage Gateway together. This is where you would collect data with the Snowball, you would ship the Snowball back to AWS, we copy it into an S3 bucket, and you can then make that data available via NFS using a file gateway. So if you're doing a large-scale migration, moving lots of data, from on-premises into AWS. This is the way that you can get it there very quickly and then still maintain the traditional access over NFS to be able to use that data inside of the data center. So a quick example of a customer that's doing that today. Moderna is a pharmaceutical company, and they're using the storage gateway in file mode, or the file gateway as we call it, to be able to write data from all of their instruments, things like mass spectrometers, electron microscopes, that natively support NFS. They're writing those test results into the file gateway. That data gets transferred up into S3, and it can be archived for long periods of time, and it can also be processed very quickly. So doing something like spinning up spot instances to take advantage of low-cost, on-demand compute, process the data, get the results back again via the file gateway. It's a way for them to do this very quickly and to do it for much less cost than if they were trying to build out that same environment inside of their own data center. The volume gateway, again in the storage gateway family, the volume gateway provides local iSCSI access. So in this case, you deploy your virtual machine, you then provision up to 32 LUNs in what we call cached volume mode. And what that means is that you would have some amount of cache there in the local gateway, and you can provision up to 32 LUNs of 32 terabytes each, so you get up to a petabyte of total storage per gateway, even though you have much less than that sitting in the cache. And all of that is backed by S3 and EBS. So you format the LUN with the file system, you write data to it, the most recent data is stored in the cache on the gateway, and everything gets copied back into S3, and at any point in time you can take a snapshot of that data, and all of that data is stored as an EBS snapshot, and you can do a couple of things with that snapshot. One is you can actually assign it and give it to a workload that's running in EC2 as a native volume, as an EBS volume. And so this is a way that you can actually migrate data from on-premises into AWS and have it show up as an EBS volume that you can connect directly to a workload running inside of EC2. Of course, you could also use those snapshots for backup or even disaster recovery purposes. All of the data is compressed as it's in flight and sitting inside of that S3 bucket. So you may write 100 gigabytes of data, and if you're getting 2-to-1 compression, in that case, we will be storing just 50 gigabytes of data in the service, and you'll only be billed for 50 gigabytes. And I mentioned the cache volume mode. We also have a stored volume mode. And a stored volume mode provides a one-to-one mapping of the capacity that you've provisioned on the LUN. So let's say you provision a 16 terabyte LUN. You will need to have 16 terabytes of disk in the volume gateway acting as the cache, and we will always keep that in sync. So if you have 16 terabytes in your volume, you'll have 16 terabytes in the cache and 16 terabytes sitting in S3. So we keep those in sync across everything. And just an example of a customer that's using volume mode today, we have Just Giving in the UK, and they connect charities with donors and give the charities a way to be able to take donations. And they're using the volume gateway to store their OLTP and OLAP data. As they're working with it locally, all of it is being serviced, all the I/O is being serviced from the local volume gateway. And then they're taking snapshots, and those snapshots are being stored back as EBS snapshots in AWS. And so they use those for disaster recovery. They also use them as they're archiving data off. You can see that they're using a separate AWS account where they're moving that data off, and they're even using it for backup purposes. And I recently talked to the storage administrator from Just Giving, and what he told me was he loves the service because he doesn't have to think about it. It just runs in the background. He's built his snapshot schedules, and he knows that his data is automatically off-site. It's being stored in AWS, and he doesn't have to think about does he have replication bandwidth, or does he have enough capacity in a remote array, or does he have enough tapes to be able to take his backup. It just works. And so the last part of the storage gateway family that we'll talk about is the tape gateway. And the tape gateway provides a virtual tape library. You can see that we have in the graphic there a media changer and tape drives. So in one virtual tape library, we'll give you 1,500 slots with 10 drives and the robot to be able to move those virtual tapes around. So your backup server connects via iSCSI to the virtual tape library running inside the tape gateway. And again, this is a virtual machine that you deploy either on premises or inside of EC2. And you can write data through your backup application, and you can see down at the bottom some of the leading backup applications that we support, things like Veritas Net Backup in Backup Exec, Dell EMC, Networker, Veeam, HPE Data Protector, ArcServe, and even DPM from Microsoft. So you can write data to these virtual tape drives. And one of the things that's very interesting about the way that the tape gateway works is if a tape is inside of the virtual library, whether it's either in a drive or in a slot, that means that that data is being stored inside of S3. So just like on premises, if you have your physical tape library, or you have a tape in the library that you've backed up to, our equivalent for that is the data is sitting in S3. When you export the tape out of the import-export slot using your backup software, we then copy that data into Glacier and we mark it as read-only. So that's sort of the equivalent of taking the tape out of your library, putting it into a lockbox and sending it to off-site storage at a provider that will do the pickup and lock it in a vault someplace. And so we allow you to take that workflow that you have today inside of your data center and to be able to transfer it into AWS so that you can still take advantage of the backup software that you have today, still have the same workflow with being able to write to tapes and then being able to send those tapes out of the library for long-term archiving and long-term storage. And a great customer use case and case study that we have, this is actually one of my favorites, is Southern Oregon University. And it's one of my favorites because they're doing something very creative that I hadn't thought of when I saw this. And what they're doing is writing data to their local storage gateway in tape mode that's running in Southern Oregon. And one of the things about the tape gateway and the volume gateway is that they write data to the AWS region where they were activated. So in this case, you can see that we're showing the little box there for Oregon and then a box again in Northern Virginia. And what Southern Oregon did was they activated their tape gateway into US East 1. And so that means that when they write their data locally, they write the tapes, we're actually transferring the data over the internet into US East 1 in Northern Virginia. And so this means that they of course have their production copy of the data in their data center locally in Oregon, but when they do their backup and even do their archiving, that data is all being stored on the east coast of the United States in Northern Virginia in the AWS facilities there. So this way they get, their words, a bi-coastal data center. And so it gives them very large geographic separation of their primary and secondary copies of their data. So if something were to happen locally, they would then be able to manage that and recover the data inside of AWS on the East Coast. So the next thing that we're going to talk about is EFS with Direct Connect. And as we talked about before, EFS is our elastic file system, and it provides NFS access kind of similar to a NAS device that you would run inside of your data center, except inside of AWS and inside of EC2. And recently we announced, again at reInvent back in November, that you'd be able to connect via a Direct Connect, which is a private connection that you can purchase into AWS from your on-premises servers. And there are a couple of different things that you can do with this. And if we kind of break it out, of course one is migration. If you're moving all of that data into AWS and you're going to be moving your applications into AWS, you can move that data over a Direct Connect into EFS, you move your applications into EC2, and then they can mount the data that's been copied into EFS, and you can essentially recreate the environment that you would have inside of your data center, except doing it inside of AWS and getting the access to the scalability of EC2 as well as EFS. You can, of course, burst data, and bursting is when you would temporarily move a data set. So we have some customers that have maybe had a workload that has grown very quickly, and before they can get additional storage on site, they need some place to put data so that they don't fill up their primary storage system in their data center. And we've had customers that will use a Direct Connect and copy that data into EFS for temporary storage until they can either make more capacity in the data center or add capacity to their existing array, and then they will move the data back down. So it's a temporary place, and of course you can even do that for processing. So potentially you would move data up into EFS over the Direct Connect, mount it via maybe spot instances that you deploy inside of EC2, process the data, and when it's finished you can copy it back down. And the last piece is backup and disaster recovery. And so you can maintain a copy of an entire data set inside of EFS over a Direct Connect, or even use it as a backup target to be able to store that data natively to NFS and get the performance that's available from EFS. The next thing we're going to talk about is Kinesis, and this is really focused on streaming data and IoT type data. And one of the things about Kinesis is that it gives you the ability to very quickly process and use data. And so if you think about the time value of data, if you're processing data in real time and you can make critical decisions in seconds or potentially even out to minutes, near real time, there are a lot of things that you can do with that data that potentially are more valuable than if you were to do it hours or days or even months later. Of course, we're always coming up with new ways to mine data and ways to reuse data that you already have. But if you think about data that's coming in real time, being able to take action on that data is very interesting. And so with Kinesis, there are a couple of different things that you can do. We're primarily going to focus on Kinesis Firehose today because there are three different pieces of the service. So we'll talk about Firehose and some of the things that it can do. So on this slide, you can see that some data types that you would think about for Kinesis, things like real-time processing and storage of logs, whether it's application logs or logs from infrastructure devices, firewalls, routers, things like that, where the data is coming in, you're streaming it, and you want to be able to process it and look for anomalies in real time. Or things like social media, click streams, or even sensor device data. If anybody has a connected thermostat in the house or security cameras or anything like that, that's all data that's going to be going someplace. And if you can analyze that in real time, think about a connected smoke detector. Not only do you want the alarm to go off, but wouldn't it be great if somebody could realize in real time that there's a fire and be able to call the fire department? That's the type of use case where you'll see things like Kinesis. And so the three different parts that make up Kinesis, the first is Kinesis Streams, and this is storing the data as a replayable stream. So you write your application, you point it at the Kinesis service, and the data streams in, it gets buffered, and you can process that data in real time and even replay that stream at a later date. What we're really going to focus on today is Kinesis Firehose, and Kinesis Firehose is a way to take that data that's streaming and it's coming in over the internet and direct it right into an AWS service. So Kinesis Firehose is a fully managed service and it delivers the real-time streaming data to destinations like S3 or Redshift or even Elasticsearch. So you can point those streams directly into the service where you're going to get the most value out of it. And you don't need to write a custom application. You don't need to manage the resources. You simply configure the data producers, the devices or applications that are creating the data, to send their data to Firehose, and then it will automatically deliver the data to the destination. So just to match kind of the services and the scenarios, Kinesis Firehose is, again, as we just talked about, a way to ingest that data and even transform it before it lands. So you can have data coming into Firehose, you can filter it and process it and convert it and have that written, say, to an S3 bucket, And you can even write a backup of the original unprocessed stream to a separate S3 bucket, so you can maintain those two separate copies, one being the original format and one being the transformed version. And then with Kinesis Analytics, this is where you get the metrics, and you can use SQL queries to pull information out of the data stream as it's coming through. And with Kinesis Streams, this is where you can analyze the data and be able to make real-time or near real-time decisions based on the data that's coming in. Just a couple of quick use cases. I think the most interesting one to me is Sushi Row. They're a chain of sushi restaurants in Japan. And one of the things that they're doing that's really interesting with Kinesis is they have sensors on every one of the plates. And it's the type of restaurant where the chef makes the sushi, they put it on the plate, and then it travels around the restaurant on a little belt. And if you're sitting at a table and you see something that you like go by, you take the plate and eat your sushi. And they do a couple of different things with the sensors that they're using Kinesis for. One is they can keep track of the price and all the plates that you've taken and what the total cost is, but they can also manage, if you think about it, kind of the life cycle of the sushi. Nobody wants to go into a sushi restaurant and eat sushi that's been sitting for 30 or 45 minutes. That makes me uncomfortable just thinking about it. And so what they can do is when the sushi is prepared and it's put on the plate, they can scan the plate and they know the exact time that it was made and when it was put out onto the belt, so they know when it's fresh and when they actually need to take it back off. So it's a way for them to, in real time, manage the restaurant experience, not only to creating the food and distributing the food, but even how they're going to charge their customers. And so they've been able to enhance that experience. Then, of course, Major League Baseball is using AWS and Kinesis to power their applications so that they can provide real-time stats and information during baseball games. And one of the things for Major League Baseball was being able to spin things down in the off season. So if you think about a baseball season, you don't want to necessarily buy all of the hardware to be able to do this. Put it in your own data center and only use it for, and I have to confess ignorance here, I don't know how long a baseball season is, but let's say it's 9 months. You don't want to have that hardware just sitting idle for 3 months. Essentially, you're throwing money away at that point. So by using AWS and using Kinesis, they're able to spin up the resources that they need while there are games happening, and then spin those resources back down either during the off season, or if there's say a slow week, they don't have to keep all of that infrastructure running. So just to recap on Kinesis Firehose, you have an application or a device that's creating the data. You point that data stream to Firehose, and then you can put it in things like Elasticsearch or Redshift or S3, and then run analytics on it and even process the data to be able to get insights and information out of it. And so the last thing that we're going to talk about is S3 transfer acceleration and ways that it can help you speed up access to data that's in S3 buckets. And so with S3 transfer acceleration, if you think about the way that the internet works in transferring data over the internet, in this case, we have, it looks like a user in India. They're connecting to an S3 bucket that's in the east coast of the United States, so they are quite literally going around the world, or halfway around the world. You have high amounts of latency. If you're going over the internet, you have the potential for packet loss, you have bandwidth constraints, you have out-of-order packets. And if you think about the way that networking works, when you have high latency and you have any amount of packet loss, that's going to severely limit the throughput that you're able to achieve when you're reading or writing data to or from S3. And so we can't solve for latency. No one can really solve for latency. It's a speed of light issue. You can't make light go any faster, but we can change the underlying network to make it more reliable, to make it more consistent, reduce the packet loss or eliminate packet loss and out of orders, as well as we can help manage for the effects of latency by doing things like increasing the window size. And so with S3 transfer acceleration, The only change that you would make to how you connect to S3 is you change the endpoint name, and you use Route 53. And what will happen is it will connect you to the closest AWS Edge location. And once you connect to the AWS Edge location, we then use our content delivery network sort of in reverse to be able to efficiently move that data from the Edge location to the S3 bucket location. So in this case, we would be going from India back to the East Coast, but as the end user in India, you're connecting to the local AWS Edge location or POP. You're reading and writing all of the data, and you're having that local round trip time, local transaction, and then the rest of the way from the POP location or Edge location back to the S3 bucket, all of that data is traveling over the AWS or the Amazon network. And so then we get the benefits of high throughput. We manage the effects of latency by controlling the window size, TCP window size as that data is being sent, and that allows us to make more efficient usage of the bandwidth that's available, unlike what would happen typically with an application where it has a very small window size. And to give you an idea of the benefits that S3 transfer acceleration can provide, we do have a calculator on the website, so if you can go to the AWS website, go to the transfer acceleration page, and there is a calculator where you can put in where you are in the bucket that you're going to, and it will show you what we think the benefits are going to be. But in this case, you can see that we're in Singapore, or the end users in Singapore, and if they're going over the internet or they're going over S3 transfer acceleration, you can see the time is essentially the same. And that's because it's low latency, and so the effects of packet loss or out of order are going to be much lower because we have that lower latency, and so they're getting fairly fast throughput. Now, as we start to move to the left, we're starting to get farther and farther away from the end user or from the bucket, and you can see that all the way at the left, when we get to Rio de Janeiro, with S3 transfer acceleration, it does take longer than if we were connecting locally inside of Singapore, but we are less than half of the amount of time that it would take to go over the public internet. And an interesting customer use case for this is Huddle, and Huddle provides game film and video for coaches to be able to use with teams. So if you think about football season in American football, a lot of colleges, a lot of high schools, plus professional, all things happening at the same time, they're capturing video during games and during practices, and they're capturing 35 hours of video every minute. So this is all of their customers are capturing video at the same time, 35 hours of content per minute, and they're uploading it into S3. So the data is coming from the end user, capturing the video, using S3 transfer acceleration. It lands in an S3 bucket. They're transcoding it, they're processing it with Redshift, and then they are making it available again back to the coach or back to the staff to be able to use with the players. And so they're coming out of S3, they're using CloudFront, and then it's being delivered to the application. And what they've seen is that using S3 transfer acceleration, they're getting greater than 20% increase in their upload speeds, which also means that they're able to encode transcode and process the data much faster and get those results back to their customers. And so just a summary of what we've talked about so far of AWS tools. If you're doing an offline data migration, Snowball, Snowball Edge, or Snowmobile is the solution for that. If you're doing a data migration online and you need to be able to have access and to be able to work with the data in real time or near real time, that would be Storage Gateway or EFS over Direct Connect. If you're bursting data into AWS for temporary storage or for quick processing, that would be Storage Gateway or S3 transfer acceleration, potentially even EFS over Direct Connect. If you're tiering data from on-premises into AWS, Snowball Edge if the data can be offline, Storage Gateway if the data needs to be online, and then for backup, again, Snowball if the data can be offline, Storage Gateway, EFS over Direct Connect, or even one of our third-party partners if the data needs to be online. And speaking of third-party partners, let's finish there. We do have a vast portfolio of storage partners that have built in native access into their applications to be able to go directly into S3 infrequent access, or even into Glacier. And so you can see from left to right, we've got primary storage vendors like NetApp and Avere and Panzura. We have backup and recovery vendors like Commvault, Veritas, Dell EMC, IBM. Moving over to archiving with Commvault and NetApp, business continuance disaster recovery with Zerto or CloudEndure or Druva. And if I didn't read a name on the slide, it doesn't mean anything. I'm just sort of picking them out as I go. But all of these vendors have built in native support into their applications, and there are even more than what we're showing on the slide. But it means that with something like, say, Commvault or Cloudberry, you can deploy the software, you can natively connect to S3 or to Glacier, and you can start moving data, backing up data, doing your disaster recovery, or tiering data right into AWS using an application that you already have in production today. And so with that, we've got about 12 minutes left, and I think that we've got